ज्वाइंट हो गया वो थर्सडे को ये फ्राइडे को तो ये आज ज्वाइंट हो गए सैटरडे को ये लोग ज्वाइंट हो गए सैटरडे को आपने बोला ना जब मैंने अभी 2 घंटे पहले ही बोला so we have a equation that is the 500x1 plus 1000 x2 plus x1 x2 50 x1 plus 40 x2. So this is the enthalpy relation is given with certain temperature and pressure. Now we have to obtain expression for the બોલો નથી લાગતો તો બીજો લખ 95 74 18 47 08 so we have a we have to obtain an expression for H1 bar and H2 bar in terms of X1. We have an expression for H1 bar and H2 bar in terms of X1. Okay, so this is the first question. So let's introduce the let's give the answer of this question. So um, solution. So we have a h1 bar is equal to h plus 1 minus x1 dh divided by dx1. Okay, so what we have to do, we have to find out dh divided by dx1, then we have to multiply it by 1 minus x1, then we have to put down the h 1 minus x1 multiplied by dh divided by dx1. Okay, so we have a first, let's obtain dh divided by dx1. Okay, so let's obtain the dh divided by dx1. So how to obtain dh divided by dx1? We have a h is equal to 500 x1 plus 1000 x2 plus x1 x2 50 x1 plus 40 x2. Okay, so let's obtain dh divided by dx1. Kindly help me to okay, let's do it. So dh divided by dx1, the h is equal to, we can also do it here. Okay, let me do it here. Okay, dh divided by dx1. Okay, so differentiation in respect to x1, so x1 will be cancelled out. So here 5. Okay, now here differentiation is 1000 dx2 divided by dx1. Then now here these both are in multiplication. So first will be constant, then do the differentiation. Then second will be the constant and do the differentiation of first. So multiplication rule for the differentiation is applied. So x1, x2 will be common. Now we have to do the differentiation of this one. So 50, x1 differentiation 1 plus 40 differentiation dx2 divided by dx1. Okay. Now this one will be the constant plus now the differentiation x1 multiplied by x2, L multiplication rule. First, on this differentiation is 1, so only x plus uh, uh, x1 will be constant and dx2 divided by dx1. Okay, so this is the differentiation of dh divided by dx1. Okay, so let me write down again in second number page. So dh divided by dx1. Again, I am writing down it 500 plus 1000 dx2 divided by dx1 plus x1 x2 50 plus 40 dx2 divided by dx1 plus 50 x1 plus 40 x2 x2 plus x1 dx2 divided by dx1. Okay. Now again we understand what we have to obtain an expression for h1 bar and h2 bar. This is the examples of partial property of binary mixture that we did in last class. Okay. And to obtain h1, first we'll obtain h1 bar, then we obtain h2 bar. So h1 bar, how can we obtain? And in terms of x1, here the particular they are written in terms of x1. So h1 bar is equal to 1 plus x2. So instead of x2, we write down 1 minus x1, dh divided by dx1. So first we'll find out dh divided by dx1. Then we multiply it by 1 minus x1. Then we plus h, and we can get the h1 bar. This is the our things. So dh1 divided by dx1 we put. Now we have to remove the x2 because we are remaining only uh, uh, 1 minus x1. So let's put it all this. We remove dx2 divided by dx1 by something. So we have only either then we can convert it to the only x1 terms. Okay. So let's do it. So dx1 plus x2 is equal to 1. So if I, what we can do, x1 is equal to minus x2. Oh, sorry, we cannot write down like this. So we have to do the differentiation. So dx1 differentiation, dx1, a differentiation of 1 is 0. Here dx2, so dx1 is equal to minus dx2. So we can say dx2 divided by dx1 is equal to minus 1. Let's put this dx2 divided by dx1 is equal to minus. So dh divided by dx1 is equal to 500. Now dx2 divided by dx1 is equal to minus 1. So minus 1000. It's a 1000, yes. Yeah, it's a 1000 x. So 1000 plus x1 x2 as it is, 50 minus 40 plus 50x1 plus 40x2 plus x2 minus x1. dh divided by dx1 is equal to minus 500 plus 50 minus 40. Okay, what we can do, 50 x1 x2 minus 40 x1 x2, so we can say 10 x1 x2. So we can write down like this, just 1 minute. We can say minus 500 plus 10 x1 x2. 50 here it is in multiplication. It's not it's in multiplication, huh? So 50 x1 x2 minus 50 x1 square plus 40 x2 square minus 40 x1 x2. Then so if I remove x1 x2 terms, then we can say dh divided by dx1 is equal to minus 500. Now x1 x2, 10 50 60 minus 40, it means that plus 60 minus 40, it means that 20 x1. Here x2 square, 40 x2 square minus 50 x1 square. Okay. Right? So we get dh divided by dx1. Okay. Now we multiply by 1 minus x1. So multiply by 1 minus x1. So we obtain 1 minus x1 dh divided by dx1. So 1 minus x1 dh divided by dx1 is equal to 1 minus x1 minus 500 plus 20 x1 x2 plus 40 x2 square minus 50 x1 square. Okay, so once I do it, first we multiply by 1 and then we multiply by x1 here. So minus 500 plus 20 x1 x2 plus 40 x2 square minus 40 x1 square minus minus plus 500 x1 plus minus 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 20 x2 x1 square minus 40 x2 square x1 plus 50 x1. Okay, so we get 1 minus x1 dh uh, divided by dx1. Okay, so if I put h, so now we have h1 bar is equal to h plus 1 minus x1 dh divided by dx1. So let's put h and let's put this value. If we do it, then h1 bar is equal to, first we put h value. H value will be the 500 x1 plus 1000 x2 plus x1 x2 50 x1 plus 40 x2 500 plus 20 x1 x2 40 x2 square 50 x1 square 500 x1 minus 20 x2 x1 square minus 40 x1 x2 square plus 50 x1 cube. The whole relationship. Then, so what we do? Either we have to first make one equation having x1 x2 in terms of whatever we have to cancel out, that we cancel it out. Then here in between there is a plus sign. H1, what here it's a plus, so after h we have to put it. So after h here we have this sign here. So let me count one equation will form. Whatever we have to cancel it out, that we cancel it. So 500 x1 plus 1000 x2 plus 50 x2 x1 square plus 40 x1 x2 square minus 500. So plus minus 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 500 plus 20 x1 x2 plus 40 x2 square minus 50 x1 square plus 500 x1 minus 20 x2 x1 square minus 40 x1 x2 square plus 50 x1 cube. Okay, so let's take the number which anyone which don't have any number. Yes, this is the terms we don't have any number, so let's put down first. So it's a minus 500. Okay, we have to stand x1, the terms we having x1 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 x1. Yeah, it's a x1 square, so it's not cancelled out. So 500 plus 500, it's a 1000 x1. Now same with x2, this one is a x2. Rest we don't have x2, so it's a 1000 x2. Then x2 x1 square. So this is the 50 x2 x1 square. Anyone will have a x2 x1 square? Yes, this one is x2 square. So 50 minus 20, so 30 x2 x1 square. Now anyone having cube? Now we have only one cube, so we have 50 x1 cube. Now 40 x1 x2 cube square, 40 x1 x2 square. So it is a cancel out. This 40 is 20 plus 20 x1 x2 and rest is this square. So 40 x2 square minus x1 square, we have 50 x1 square. Yes, this one. Okay, so we finally generalize one and okay. Let me do this here. One thing is 1000 x1 1000 x2, so minus 500 plus 1000 x1 plus x2 plus rest we put as it is 30 x2 x1 square plus 50 x1 cube plus 20 x1 x2 plus 40 x2 square minus. Just 1 minute, please. So now 40 x2 square minus 50 x1 square plus this one. Okay, now x1 plus x2 is equal to 1. So if I put 1, so minus 5000 plus 1000 minus 500 plus 1000, so it's a 500. So finally h1 bar is equal to 500 plus 30 x2 x1 square plus 50 x1 cube plus 20 x1 x2 plus 40 x2 square minus 50 x1. Then okay, so they are saying that we have to uh, we have to read the answer in terms of x1. So here we replace x2 is equal to 1 minus x1. So h1 bar is equal to 500 plus 30 x2 is equal to 1 minus x1 sorry x1 x1 square 1 minus x1 plus 50 x1 cube plus 20 x1 1 minus x1 plus 40 1 minus x1 square minus 50 x1 square, here 50 x1 square. So h1 bar is equal to, finally we have, once I put down and I remove the terms, so finally we have 540 minus 60 x1 plus 20 x1. Okay, so this is the our final answer. So same way you have to find out h2 bar. You can do it at your home. h2 bar is equal to h minus x1 multiplied by dh divided by dx1. So you have dh divided by dx1. You have to multiply it by only x1. Then you have to put down the value of h. So you can get h2 bar is equal to 1000 plus 30 x1 square plus 20 x1 cube. Yeah? This is the answer. Okay, you can do it at your own. So this is the things. Now another one example we also like to do. Okay. That example is easy. It's okay if they don't know. Okay, let's do it. We'll do theory in next class. Okay, so let's do one example. It's a small example regarding the properties of binary mixture solution. So if possible, then let me copy paste the example from book. Just 1 minute. Hello. Ajay, Okay, students. So there is one example. Uh, uh, okay, let me share that example. So this is the example. We have a in a laboratory 30 mole percentage methanol water solution is to be prepared. So 30 mole percentage methanol. So rest 70% is water. How many centimeter cube of pure methanol and pure water are to be mixed to prepare 2000 centimeter cube of desired solution? So they are asking that if I want to find out the, if you want to find out the, for example, 30% of methanol, then what will be the desired solution of the methanol and what will be the desired solution of water? So V volume V1 for methanol, V2 for the water. So what is the total volume of methanol and what is the total volume of water? That's part. So to calculate this, partial molar properties of methanol and water are given. And for pure species, V1 and for pure species, volume of water and methanol are given. So let's try to calculate this example. So what they are saying that we have a uh, we have a molar volume of, we have to find out the molar volume of antifreeze solution. Uh, so where V is equal to x1 V1 bar plus x2 V2 bar. Okay. So where molar volume V is equal to x1, it means 0.3, V1 bar is given 38.632, x2 will be the 0.7. So V2 bar is a 17.765. Okay, so molar volume is once we do it, then we have a 24.025 centimeter per mole. Total volume of solution will be the 2000 centimeter cube. So total number of moles required is equal to total volume divided by molar volume. And so total volume will be the 2000. Molar volume will be the 24.025. It means 83 mole 246 are there. Total moles 83.246. So in that, how much mole of ethanols are there and how much moles of waters are there? So for methanol, ethanol 30%. So moles of percentage ethanol is at 0.3, and how much total moles? 83. So totally we have 24.974 mole, and water 70%. So total volume VIT for species is N1 multiplied by VI. So VIT is equal to N1 is 40.947. Total volume is equal to 20 N1 multiplied by N1 multiplied by V1. That pure uh, water is given, pure volume is given, pure substance volume is given 40.727. So total volume of pure species for methanol is a 1017 centimeter cube. For water, so VIT for water, pure species water, N2 multiplied by VI, where water volume is given here 58.272 multiplied by V2 is given 18.068 centimeter cube per mole. So we have 1053 centimeter cube of water. So once we are combining this one, so we are getting a nearly 2000 centimeter cube. In that, the methanol is present 1070, where water is present 1000. So with these two examples, I end this lecture here. In next class, we'll do the theory of ideal gas mixture model, fugacity and fugacity coefficient for next lecture. Okay. So I end with this lecture for all of you. We'll meet the next lecture within the ideal gas mixture and uh, uh, fugacity and fugacity coefficient. Thank you very much for joining it.
Thank you, sir. Have a good day, sir.
Have a good day to you also. And okay, so we'll do it in next lecture. Your new timetable will be shared with you. So according to it, you have to join lecture from Monday. Okay. Thank you very much. I end.